Good morning, students. Let's we discuss the diagonal relationship. In the previous video, we have already discussed about the diagonal relationship between period second and period third of group 1, 2, 13, 14 and 15 members. Let's the similarity between lithium and magnesium. Today we will discuss about the points of similarity between lithium and magnesium. What are the similarity between lithium and magnesium? How they diagonally related to or show the property same. Lithium hydroxide is a weak base. Magnesium hydroxide is also a weak base. It is also a weak base. Lithium is hard in nature, whereas magnesium is also hard in nature. Lithium chloride is deliquescent in nature. Deliquescent in nature. Magnesium chloride also deliquescent in nature, exists magnesium chloride in this form. Lithium chloride and magnesium chloride, they show similar chemical property. Lithium carbonate decomposes. Magnesium carbonate also decomposes. Lithium exists in bicarbonate form. Magnesium also exists in bicarbonate form. So they show the similar property in spite of they belongs to different group. So students, let's we discuss the chemical property of group 2 elements, which is called the alkaline earth metal group. Chemical properties of group 2. Alkaline earth metal group. The first chemical reaction with moisture. Reaction with moisture. Element, condition of water, and reaction equation. Beryllium with hot steam. So beryllium when react with hot steam form beryllium hydroxide and hydrogen gas liberate. Magnesium also treated with hot steam, and the reaction involved is magnesium plus water, the formation of hydroxide along with hydrogen. Calcium, water at room temperature. Formation hydroxide takes place, calcium hydroxide and hydrogen gas. Strontium, cold water. So strontium plus water, strontium hydroxide and hydrogen gas. Barium also react with cold water, formation barium hydroxide, and hydrogen. So students, see here, as we move top to bottom, the reactivity of element increases. Beryllium hot react with hot steam, magnesium also react with hot steam, but as we move top to bottom, the element react with cold water also. Next reaction is reaction with alkali. The most reactive element is the group 1 member, and group 2 members are less reactive than group 1. Next reaction is reaction with alkali. For example, beryllium when react with sodium hydroxide to form a compound Na2BeO2 plus H2. So it shows that this element is amphoteric in nature. Being a metal, it reacts with acid also as well as with base. So next we discuss the reaction with hydrogen. All the members react with hydrogen to form hydrides M, magnesium, calcium, strontium and barium. Reaction with halogen. All the members react with halogen to form metal halide M, magnesium, calcium, strontium and barium. Exceptional case. Exceptions. This method is not applicable for beryllium. Preparation of beryllium chloride takes place when beryllium oxide treated with carbon or coke and chlorine. This is reversible reaction. Then the formation of beryllium chloride takes place along with carbon monoxide. So the first member of this particular group is also a different behavior, anomalous behavior. So why beryllium show the anomalous behavior? So write down the anomalous behavior of beryllium. Anomalous behavior of beryllium. High electronegativity, smaller atomic and ionic radius, non-availability of d orbital, differ by other. Beryllium is hard metal, other metals are soft. Soft. List metallic. Forms covalent compound. Number 3, melting point, boiling point, ionization enthalpy, highest of all the alkaline earth metal. Highest of all the alkaline earth metal. Beryllium oxide and beryllium hydroxide. Amphoteric in nature. Amphoteric in nature, and other oxide hydroxide are other oxides and hydroxides are basic in nature. Basic in nature. So beryllium is differ by other alkali metals, so that it show the anomalous behavior and different behavior than the other members of particular group. Points of similarity between diagonally relation means beryllium with aluminum. Diagonal relationship of the beryllium. Points of similarities between beryllium and aluminum. Beryllium and aluminum. First, the parameters are, beryllium and aluminum. How they diagonally related. First, covalency. Beryllium and aluminum both form covalent compound. Tendency to form covalent compound. Number 2, reaction with acid. Beryllium does not show reaction with acid because of presence of oxides oxide layer on it. So beryllium hydroxide, when treated with alkali, it form beryllium OH whole 4 2 minus. Aluminum hydroxide react with alkali. Aluminum hydroxide also react with alkali to form aluminum OH whole 4. So in this way it treated with, it will show the relation between the alkali, similarity between with the alkali. Hydroxides in presence of alkali. Reaction with, does not show reaction with acid. Aluminium also have passive layer of oxygen on it, so mostly aluminum react with acid as well as base. Beryllium also react with acid as well as base, but not more reactive like the other member. So aluminum and beryllium show the similarity between, somewhat they show the relation between them. So next of rest of the property we'll discuss in the next video.